Hi, in this section of the video, we would like to present to you the Type B PON protection scheme. We will guide you with the concept of what is Type B PON protection scheme and how it can be configured into a Tejas OLT using the Tejas OLT graphical user interface. Here on the screen, we have presented a simple setup. So we can see here there is a diagrammatic representation of a OLT, and we have here a optical splitter and a few ONTs. So to understand the advantages and the concept of the Type B PON protection scheme, let us consider a simple setup as shown in the diagram here on the screen. So we will take a setup where there is no PON protection. We see here there is a OLT, there is a 1:n splitter. The optical splitter has a single input and it has n number of outputs, and we have n number of ONTs connected here, and each user is surfing the internet or attending a voice call on these ONTs. The traffic from the uplink flows along this path through the Ethernet SNI port of the OLT and comes to the PON port and flows through the fiber here connected to the splitter, and further upon it gets split into the different respective fiber paths and travels to the ONT users. The optical fiber present in this path and in these individual paths. Let us assume that this particular fiber is damaged or it suffers a fiber cut. Immediately the optical connectivity between the OLT and the splitter is discontinued. The optical connectivity continues to exist between the output of the splitter and the individual ONTs, and the ONTs remain active. However, the traffic is not able to flow from this path to the ONTs because of the cut in the fiber. So this is a traffic down situation. Now, if this traffic has to be recovered, we need to send an engineer or a team to this particular location. The team has to first travel to this location, and using special instruments they need to locate the position of the fiber cut on this long fiber, which could easily be several kilometers. After they locate the fault, they need to repatch the fiber and thereupon recover the optical connectivity, and then the traffic would continue to flow to the users, ONT users. So this procedure or this process may easily take a few hours and to even a day, considering the remote accessibility of these areas, and this is not acceptable. That is why many of the ISPs or service providers deploy a Type B PON protection scheme in their GPON network. This Type B PON protection scheme involves the coupling of two individual physical PON ports. So for example, here I have selected PON port number 3 and PON port number 4. So these are individual PON ports. So when I apply the Type B, for the intelligence of the OLT, the two PON ports appear as a single virtual PON port. Out of these two PON ports, one PON port will be active and other PON port will be standby. So the traffic from the uplink will flow through the active PON port and through the fiber here, which I have labeled as path alpha, and then it will get distributed in the optical splitter here, and the traffic would further upon get distributed to all these ONTs. And the same happens in the reverse direction, in the upstream. Each ONT would communicate in its time slot to the PON port via the path alpha fiber to the respective PON port. Now let us assume that there is a fiber cut in path alpha. So immediately the OLT has the intelligence to sense that there is a cut and it would raise an alarm, and instantly it would switch the traffic to the PON port number 4. So the PON port number 4 would become the active PON port, and the PON port number 3 would become the standby PON port. So all the traffic would start flowing through the path beta, and all the ONTs here would start receiving the traffic from the path beta. So for ease of understanding, I am giving here the color code. We can see here all the ONTs start receiving their traffic from the path beta. So this is the concept of the type B PON protection scheme. No traffic down observed by the users of the ONTs. Let us say that the field engineering team restored the fiber. The traffic would still continue to flow on the blue path or the path beta, because this continues to be the active port. NOC engineer could manually switch the port status from active to standby, and he could recover the PON port 3 into the active status, and he could replace the PON 4 into the standby status. He will be able to switch all the traffic back to path alpha. So now let us go into the actual configuration of the scheme into the Tejas OLT. So let us open the OLT GUI, login window of the OLT. So the default password is J72E#05T. So here we see there's an OLT which is still in an unconfigured state. All the PON ports have a cap on them. You can see the X mark. So there are no fiber or SFP connected. So let me go back to the diagram. So I want to apply my type B PON protection scheme on the PON 3 and PON 4. First, I need to activate these ports and insert the SFPs on these two ports to the PON port. See here PON port number 3 and PON port number 4. Click PON port number 3 and we click activate. We can label the PON port. So I am giving this as path alpha as seen in the diagram. PON 3 is carrying the fiber which is laid in the path alpha. Click submit. Next we go back to the PON card. We see the PON 3 is showing as A, which means activated. We go to PON port number 4. Here, then admin state activate, submit. So now we see that the two PON ports are in activated state. Now let me insert my SFPs. So they would get displayed here. First I connect the SFP on PON 3. Meanwhile, we can also see in the diagram here, the port 3 and port 4 are activated. Since the fiber is not yet connected and link is not through, it is in red color. Now the port number 3, I will be connecting the SFP. Immediately we can see here in the inventory table, you can see that an SFP has appeared here. Next, let me connect the SFP on port number 4. Immediately we see that an SFP image has appeared here, and in the inventory table we can see the presence of the SFP. Let us apply the PON protection scheme. A very important point here is there should be no ONTs on these ports when configuring the PON protection scheme. So let's ensure that there are no ONTs on these ports. So here we see the manage ONT window. Absolutely there are no ONTs present. So let's navigate to the GPON folder. Under GPON folder we have the PON protection tab here. click on Add PON Protection. I want port number 3 to be the working port and port number 4 to be the standby port as seen in the diagram here. I give a name Tejas Lab Test Type B to identify the set of ports. Click on Provision and then report to OLT. So we see here the message successfully reported the creation of PON protection. We go back to the PON protection tab. As seen in the diagram here, we can see that port number 3 is configured as active and I have laid a fiber in the name path alpha, and on port number 4, which is configured as standby port, I have laid out a fiber path beta. So these two fibers are arriving at the two different inputs of the 2:n. On this side, I'll be activating two ONTs. Let us verify in the OLT GUI. So the left side, we have the GPON folder and we navigate to the maintenance folder and then manage ONT. We can see that there are two ONTs in activated state and they are online. So they have been tagged to PON port number 3. Next, let us verify the PON protection status. We can see here, this is the label of the PON protection pair. In this pair, there are two ports, port number 3 and port number 4. So the current switchover status is displayed as normal because this is the desired port on which the traffic is currently active. And port number 4, the status is displayed as standby. We see a button here, switchover. So this is to be used for any manual diversion of traffic as desired by the NOC engineer. Next, let us verify the individual port statuses. We go to GPON port. Here we see port number 1 and port number 2. They are currently deactive and they are unique ports which are not a part of any PON protection scheme. However, port number 3 and port number 4 are clubbed together and shown here as a single virtual port, and they have been marked by the name PP or PON protection pair. We see all the ONTs are tagged with port number 3 because originally when we connected the ONTs, the PON port number 3 was nominated as the active port. Next, let us simulate the fiber cut scenarios. We will open the alarm window, navigate to fault, active alarms, and let us also track the event history. So as we see now, no alarms are there because the port is active. There is no fiber cut. Let me open the individual port status here. The port number 3 is in operational status up and the port number 4 is also operational status up. Now let's create a fiber cut scenario on port number 3. The moment we create a fiber cut, we expect that the active status immediately shifts to the port 4 and the port number 3 becomes the standby port. All traffic will begin to flow on PON 4. So let's initiate the fiber cut. We go back to the OLT UI. We see this is a port number 3. We refresh the screen. We can see that the operational status of port number 3 is down and port number 4 continues to be operational status up. let's navigate the alarms. We see that 3 alarms have appeared. The most important alarm being the loss of signal, and we can see the date and time stamp. The loss of signal has appeared on port number 3, and we can see the port description on the path alpha. The loss of signal alarm has appeared, and we also see other pairing alarms. Type B protection unavailable. So this is explained from the PON protection window. So let us refresh the status of the PON protection window. We see that earlier it was showing the normal operation state. Now it is displayed as switched. Port number 3 has become standby and port number 4 has become active. So what this indicates to the knock operator is that earlier the PON protection was available because on both the paths the fiber was safe. But now, since one of the path is down, the protection scheme no longer holds good, because the fiber is now present only on the port number 4, and in case there is a single point failure, the entire traffic on the full tree would be down, and all the ONTs here would be down if there is a second fiber cut on this path. That is why we see the alarm type B protection unavailable. Then we see the third alarm. It states that the protection is now switched to the protect port. So this is as expected, because we had nominated port number 3 as the work port, and for us the port number 4 is the standby port. Let us restore the fiber. An important point to note: once the fiber is restored, there would not be a automatic switchover of the traffic or the port statuses from active to standby. However, we would receive an indication that the path is clear or the earlier alarm is cleared. So let's again go back to the OLT. So this alarm needs to be cleared, which can be observed from the event history window. So we immediately see that the alarms have been cleared. Let's see in the event history window. We see the green highlight here. Port number 3 cleared, loss of signal. And even the type B protection unavailable, the alarm has been cleared, which means that the protection scheme is again back in operation. So let's go to this window. We'll refresh the status of the PON protection window. Here we see that there is no change in the statuses. It continues to remain in the switch state, because as I had said, there is no mechanism for a auto switchover back to the original port. The knock operator has to manually up the port. Now going back to the individual port status window, let us refresh the screen here. We would see that the operational status is up again, because the fiber is restored on the path alpha. And we see here this is the path beta is continues to remain up. So let us do a manual switchover and clear this alarm. This alarm indicates that the traffic is continuing to flow on the protect port. We trigger a manual switchover, click yes. Ensure that during the manual switchover operations there is no fiber fluctuation or unwanted manual disturbances for at least 15 seconds. Let us navigate back to the PON protection window. And we immediately see that the switchover status is back to the normal state, and PON 3 now has regained the active working state, and the PON 4 has gone back to the original standby state. Please remember, during this manual switchover process there is no traffic impact. Let us see the clearance of the alarm. So we see here again that the alarm has been cleared, and this is also noted down. The traffic which was running on protect port, the warning is now cleared. Now let us see the other combinations of the PON protection state. Right now we see that the switchback has happened. PON 3 is active and PON 4 is standby. We'll create a fiber cut on the path beta. So this is the port number 3. The port number 3, the operational status continues to be up. Port number 4, the path beta is showing as up. We need to refresh the page to get the latest status. Now we see that the status is down for path beta. So we see that the port number 4 is right now down with a loss of signal alarm. There's an indication that the type B protection scheme is no longer unavailable. So it's a warning that the traffic is dependent on a single path, and anytime the traffic would be down in case of an additional fiber disturbance on this path. Let's see the event history. So we see that the loss of signal alarm has appeared now on port number 4 on the path beta, and the protection scheme is unavailable. Why it's unavailable? Because there is a disturbance on path beta. The same is also labeled in the alarm window. We can see the label path beta against the alarm. However, the PON protection window, the status remains unchanged because it remains in the normal state, because our original port number 3 was nominated as active, and that port does not have a disturbance and it continues to be in the active state, and the port number 4 continues to be in the standby state, however indicating a failure on that particular path number 4. Now let us restore the standby path. We'll restore the fiber, and we would like both the alarms to be cleared. So we see that the port number 4 has been restored, so that is why the alarms got cleared. Let's verify the port number 4 status. So this 3 continues to be up, and this is the port number 4. Path beta is down. Let's refresh this page. We see that path beta is up and path alpha is also up, and the alarms have cleared, which is verified from the event history window. We can see here the loss of signal has been cleared on path beta, and the protection was unavailable because path beta was down, but now even that alarm has been cleared, saying that the type B protection is fully available to the user. So let's refresh the PON protection page window. We see that there is no change of any statuses here. They continue to be in the original state. So with this demo, we come to the end of our guide on how to deploy the type B PON protection system on a Tejas model OLT. Thanks for watching the video.